Welcome to the final part of our review, section D of our internal assessment 2 of data science, where we focus on Python data structure concepts. While the previous sections covered theory, this section covers the practical tool we use to implement those algorithms. We will examine the crucial differences between lists, which are mutable, and tuples, which are immutable. We will also look at specialized structures like sets for unique elements, dictionaries for the fast key value lookups, and the heap queue model for managing priority queues. Understanding when to use which structure is vital for writing efficient code. Welcome back, everyone, to the final part of our internal assessment 2 of data science. In this part, we'll cover section D of our internal assessment 2, which focuses on the concepts of data structures in Python. Let's go through each question with clear explanations. 41. Lists are ordered and mutable, meaning that they can be changed. So in Python, list is most versatile data structure. Ordered means that the item stays in the specific position we put them, such as index 0, index 1, index 2, or etc. Mutable is a key property set here. Means that we can modify the list in place without creating a new object. We can append items, remove them, or change a specific value. This flexibility makes list a go-to choice for maximum data allocation of data. Sorry, dynamic allocation of the data. 42. Tuples different from list because they are immutable. A tuple is essentially a read-only list. If we define it, we cannot change, add, or remove elements in it. This immutability provides a few major advantages. First one is safety. It ensures that the constant data like configuration setting or the coordinates isn't accidentally modified by our code. Second one is performance. Tuples are slightly faster and more memory efficient than lists because Python knows that their size won't be changed. 43. Dictionary store data as key value pairs. A dictionary or the hash map in Java is designed for fast lookups. Which means instead of searching through a list item by item, we get a unique key to instantly jump to the associated value. For example, in a phone book app, the name is the key and the phone number is our value. Keys must be unique and immutable. These can be strings, numbers, tuples, or any other data structures. While values can be anything, such as list, other dictionaries, or the objects. 44. Set contain only unique elements. A set is a mathematical collection that does not allow duplicates. If we try to add number 5 to a set that already contains number 5, the Python simply ignores it. This makes sets the perfect tool for tasks like deduplication, which is removing repeated entries from a list. However, unlike lists, sets are unordered, which means we cannot access items by index like my set index 0 is equals to print element. This will throw an error because the items are stored based on their hashes, not their positions. 45. A DQ allows fast operation at both ends. DQ stands for double-ended queue, pronounced as Deque. While a standard Python list is fast at adding items to the end, it is slow at adding or removing items from the front because all other items has to shift over. A DQ found in collection model is optimized to perform appends and pops from both the left front and right back ends in O of one time, making it ideal for queue-based algorithms. 46. Counter is a subclass of Deque that allows trails occurrences. The counter object from collections is a specialized dictionary designed for counting. If we feed it list like apple, banana, apple, it automatically creates a dictionary apple to banana one. It includes useful utility methods like most common and which instantly returns the top and most frequent elements. Its favorite tool in coding interviews for solving string anagram or frequency problems very quickly. 47. A frozen set is a set that is immutable. Just as tuple is an immutable set, a frozen set is an immutable set also. Regular sets are mutable, which means we can add, remove items, which means they cannot be used as keys in a dictionary because dictionaries in keys are unchanging. So if we need to use a set or items as a dictionary key, where we require mapping a set of ingredients to a recipe, which is a day-to-day example, we must freeze it into a frozen set first. A heap queue model implements a priority queue. A standard queue is a FIFO, which means first in, first out. A priority queue is different. The most important or the smallest or largest item always comes out first, regardless of when it has been arrived or inserted. The heap queue model in Python provides this functionality using a binary heap data structure. It is heavily used in graph algorithms like Dijkstra's, uh, shortest path, or A star search, where we always want to process the shortest path. Coming upon 49, in max heap, each parent's node values is greater than the children. Uh, Coming upon, a heap is a specialized tree structure. It has two types, max heap and min heap. In max heap, the parent is always strictly greater than or equal to its children. The largest element is always at the root which is the topmost. And min heap, in this min heap, the parent is always smaller than its children. Here, the smallest element is at root. Python's heap queue model implements a min heap by default. So, but if if we want to use max heap, we often multiply it by -1. Coming upon the final question, converting a list into heap order is called heapify. If we have a random list of numbers, it is not a heap. We could push them one by one into a heap, which is O(n) upon log n. But heap q.heapify list is a more efficient algorithm. It rearranges the elements in place to satisfy the heap property, which is parent's node value is less than the child node value in linear time, which is O of n. This is critical optimization when initializing priority queues with existing data. So we wrapped up completely the internal assessment two of data science. Next up will be present again with some other data science concepts. Till then, keep learning. And that concludes section D and our complete internal two assessment of data science assessment review. We have covered everything from the flexibility of DQ to doubly ended operations to the utility of counters for frequency tackling. Remember, choosing the right data structure, like using a frozen set when we need a dictionary key, can significantly improve our program's performance and safety. I hope these explanations have clarified the concepts for you. Review your note, focus on the logic behind each answer, and good luck with your assessment. Thank you.